Obviously I'm not here today, but what we are going to be doing is looking at lesson 7.6. We're going to start with the warm-up here. So as always, if you don't mind, go ahead and take your notes as if I was here in class. And what we are going to be doing is a quick warm-up. Um, and then we were going to go ahead and be solving this. So the first thing what we want to do, it says let's go ahead and solve this with substitution, elimination, and then everybody's favorite, row reduction. So it'll give us a good reminder on how to do that. So if we were to solve this by substitution, and right here, I notice I have a y by itself. So if I have 7x minus y equals 19, and I want to get y all by itself by adding y and subtracting 19, we would get y is equal to 7x minus 19. And then I notice here, I know what y equals in terms of x. I'm going to plug it in the second one. So this would be 2x minus 3 times 3 times, lost my train of thought already, 3 times 7x minus 19. And that is going to equal 19. So what I'm going to do is distribute here. This will give me then 2x minus 21x. And then negative 3 times negative 19 is, what was that, negative 57? Positive 57. That's going to equal 19. And when I combine like terms, I will get negative 19x, and I'm going to minus 57 on both sides. And that will give me then, let's see, I minus these, sorry, my mental math is not the greatest. 32, I want to say. Let's say 37, 36, 38. 38. And it's 19 minus 37, so it'll be a negative 38. So then when I divide both sides by 2, I'm going to get divide both sides by negative 19, I'm going to get x is equal to 2. And now that I know what x is, I can go ahead and plug it back into either one of these. It looks a little easier on the bottom one. So over here then in red, it will be 2 times 2 minus 3y is equal to 19. 4 minus 3y is equal to 19. Minus 4 minus 4, negative 3y is equal to 15. And when I divide both sides by 3, I will get negative 3. Get y equals negative 5. So right now we know the point of intersection of these two is 2 comma negative 5. So we just solved it with substitution. We can also do it with elimination, which is always my favorite. And over here, once again, I have 7x minus y is equal to 19. And then I'll have 2x minus 3y is equal to 19. First thing that I'm going to want to do is multiply this by negative 3. This gives me, once again, negative 21x plus 3y minus 57. So then when I add these, the y's cancel. And then I would be left with negative 19x, and once again is equal to negative 38. So then when I divide both sides by negative 19, I will get then x is equal to positive 2. And I plugged it into the, let's see, bottom one. Let's plug it into the top one this time. Over here, it's going to be 7 times 2 minus y is equal to 19. 14 minus y is equal to 19. Minus 14 minus 14. Negative y is equal to positive 5. And when I divide both sides by negative 1, I get the same exact answer as y equals negative 5. So once again, when I solve by elimination, I get 2 comma negative 5. All right, so we basically just did that to make sure we got the correct answer. And now what we are going to do is we are going to solve using row reduction. It's been a long time, so if you guys remember, what we are trying to do is I'm trying to get ones in these spots. This bar represents the equal sign, and these numbers will be the solution. So you're either going to manipulate, you're going to divide, you're going to switch places, you can multiply by negative 1, all that fun stuff when you add them up. And this would represent the solution of my x. This would represent, a coefficient of 1 for my x, coefficient of 0 for my y, and that solution would be the x value. Same is true for the bottom. So the first thing that I want to do is take this then, and I'm going to take this 7x, so we're looking at the coefficients, 7, -1, 19, 2, -3, 19. So I'm really going to walk this step by step because, like I said, it's been a while. And what I'm going to do, first that I'm going to do, don't forget we need all the rules always written down, is I'm going to take row 2, I'm going to flip it with row 1, and then what I'm going to do, I'm going to combine 2 steps into 1. I'm going to take my new row 2 and multiply it by -1, and that will give me my new row 2. So if you notice, first thing what I want to do is I'm trying to get this -1 down here. Now I'm going to turn that -1 to a +1 by multiplying everything in that row by -1. So when I flip row 1 and row 2, I'm going to get 2, -3, 19. And then when I flip the first with the second, I'll get 7, -1, 19. And then since I'm multiplying that bottom row, row 2 by -1, this will give me -7, +1, -19. And now that I have a positive one where I like it, I want to eliminate everything above and below it. Now since there's only 2 rows, I'm going to eliminate what's above it. So to do that, I'm going to take 3 times row 2, add it to my row 1, and that'll get me my new row 1. So what this will look like now, my bottom row is going to stay the same. So I always write it just so I get it all straightforward. 3 times -7 is -21 plus 2 is -19. And then we're going to have 3 times 1 is 3 plus -3 is 0. 3 times -19 is that -57 we've been seeing for quite some time. Plus 19 is 58. 58 plus 19 is 38. There we go. And everything above it is simplified. And now I look at that first row. I see, what can I do? Can I do something to the second and add it to the first? Well, I don't want to mess around with the 0. So I look at all these numbers. I got -19 and 38. And I notice, wait a second here. I can see that 19 and 38 are both divisible by 19. So I'm going to take row 1 and divide it by -19. And this will give me my new row 1. So right here then, I'll have 1, 0, -2. And my bottom row has stayed the same so far. And then my last step, what I'm going to do is I want to take this 1 and I want to do something to this 1 to help eliminate everything above and below it. So in this instance, it's -7. So let's go ahead and look at green now. What I'm going to do is I'm going to take row 1, I'm going to multiply it by 7, I'm going to add it to row 2. That will give me my new row 2. So that means the first one stays the same of 1, 0, -2. And then I will have then 0, 1, and then 7 times, should be a negative, nope, it should be a +7. So that means then when I take, hold on, I made a quick mistake up here. Let's see, 19, 8. Yeah, this should have been a -38. So when I divide everything, this should have been a +2. So then going back over here, 7, row 1. Okay, there we go. So then 7 times 2 is 14. 14 plus -19 is -5. Since I changed that 2 to +2, this should be a +2 as well. I'm a little rusty as well. So like I said, I made the mistake right here. This should have been a -38 over there. 3 times row 2. So it should have been a -57. -57 plus 19 would give me a -38. My apologies there. So what we did here, guys, just a quick review, solving by substitution, elimination, and mostly what we're going to be focusing on in this Module 7, or bringing back matrices. So let's go back over here. In the previous lesson, we learned how to find a multiplication of an inverse of a matrix. So let's go and review that process. As a quick reminder is, what do I need to multiply this 2 by 2 matrix? So what are my 4 variables of A, B, C, D? Zoom in here for a second. Of A, B, C, D of this 2 by 2 matrix in order for me to equal the identity matrix, which is 1, 0, 0, 1. So when I do that then, if we remember here, this would just be 5A plus C is equal to 1. And then we would have 6A plus 2C equals 0. And then what I want to do over here on the next part, set up my second set of equations, which would then be 5B plus D equals 0. And then I'll have 6B plus 2D equals 1. Now I have my 2 set of linear equations where I can solve for A, B, and C. And I'm going to use elimination to eliminate these C's by multiplying this one by -2. So it'll be -10A minus 2C is equal to -2. When I add these, my C's cancel, and I'll be left with -4A is equal to -2. Now when I divide both sides by -4, I will get A is equal to 1/2. So over here is my multiplicative inverse. So I have 1/2. Now I can plug in A for 1/2 in either of these. I see that 6 is even, so I like that one better. So 6 times 1/2 plus 2C is equal to 0. 3 plus 2C is equal to 0. 2C equals -3. So when I divide both sides by 2, I will get C equals -3/2. I'm a little crushed for room, so let's do our best here on this. Move this over here so I can solve this with a little bit more ease. Oops. It's not going to let me, so let me just go ahead and rewrite it, and then I'll erase that. So over here I have my matrix of 1/2, -3/2, and now we can solve for the other 2 pieces right here. All right, so next thing, let's go ahead and solve for B and D. Same idea, I'm going to go ahead and multiply this top one in blue by -2. And then this would give me -10B plus -2D is equal to 0. And then I still have my 6B plus 2D equals 1. These D's cancel, and I'll be left with -4B is equal to 1. And then when I divide both sides by -4, I'm going to get B equals -1/4. And now I look at these, I'm going to plug in B here. You can plug it in either the top or the bottom. I just like the even part better, so I'm going to plug it into the 6B plus 2D equals 1. Either would work. So this would give me 6 times -1/4 plus 2D equals 1. 1/4 of 6 is -1.5 plus 2D is equal to 1. When I add 1.5, this would then give me 2D equals 2.5. And when I divide both sides by 2, this would give me D equals 1.25, or 1 1/4. So then over here for B value, I'd multiply this one by -1/4 for my B value, and my D value of the matrix is 1 1/4. So now that we have this, guys, we have the multiplicative inverse, which means if I were to take this matrix, multiply it by the 5, 1, 2, 6, I would get a final solution of 1, 0, 0, 1. So we did this for the top one, and let's go ahead and see if we can do it for the bottom one. Same idea. I'm going to take this 6, 2, 3, 1, and I'm going to multiply it by A, B, C, and D in the hopes of getting 1, 0, 0, 1. So when I multiply this, this will give me 6A plus 2c is equal to 1. And then over here, I will do it again to get 3a plus c is equal to 0. And you could set up the second as well, but what I would like to show you is if I multiplied this by -2, this would give me -6 minus 6a minus 2c is equal to 0. Now when I look at my top and my bottom, these would, both the a and the c variables would get eliminated, and I would be left with 0 is equal to 1. Remember, whenever you're solving for an equation and your variables are canceled and you're left with a false statement, your answer here would be no solution. So what would that mean? This is saying that this does not have a multiplicative inverse. So were you able to find the multiplicative inverse of both matrices? And no, because what we're about to find out is the second example did not have what we call is a determinant. So no, because on number 2, there was no way to solve for the multiplicative inverse. All right, and what I did show you, some of you guys last week, it was easy enough to find what the determinant is just by looking at the graph. So there's a number associated with every matrix, as long as it has one, called the determinant. If the determinant is not equal to 0, then the matrix has a multiplicative inverse. So for a 2 by 2 matrix, the determinant can be found by using the following rule: AD minus BC. So really quickly, what is the multiplicative inverse? And essentially what it is, it's the determinant is useful for solving linear equations. It also shows us how we're capturing linear transformations. What I'm going to show you is you can find the volume. So it shows the change of area or volume and changing variables in integrals. And a more mathematical way to think of it is the determinant can be viewed as a function whose input in a square matrix and whose output is a number. So these are only going to be used for like 2 by 2, 3 by 3, 4 by 4. The bigger the square of the matrix, so going from a 2 by 2 to 3 by 3, the more complicated it gets to solve it. We are going to be focusing only on a 2 by 2 matrix. So for the sake of this class, what you need to know is the determinant is AD minus BC. And this is when the matrix is defined with the row being AB and the second row being CD. So note that the vertical line, rather than the square bracket, is used to indicate that we are finding the determinant of a matrix. So these little bars around here that look like the absolute value, it's not a typo. Those bars are identifying that we're trying to find the determinant, and the ABCD, it's representing a 2 by 2 matrix. Okay. Let's go ahead now and look at this. We can easily find the determinant of a 2 by 2 matrix by following this rule. So the first thing is, well, how would we write this? The first matrix, if you saw, which I'll go ahead and write it with us, is, get the pen, which is 5, 1, 6, 2. Remember, it is A times D, minus BC, B times C. This is A, B, C, D. So we're going to take this 2 and multiply it by the 5, and this would give me 10. We're going to take this 6, multiply it by the 1, and that would give me, obviously, 6. And so the determinant for matrix 1, we'll put these bars so we know we're talking about the determinant, would equal 4. So if I ever said, hey, can you please tell me the determinant for matrix 1, you would say, oh, it's just 4, because AD minus BC is equal to 4. Now, last week, when I was helping you, some of you guys, I was able to tell you just by looking at the matrix if it had a determinant or not. A multiplicative inverse or not, I should say. So it says find the determinant of the matrix 6, 2, 3, 1. Now notice this. If I did once again AD minus BC, which would be 6 times 1, and 3 times 2, and I subtracted this, I would get a determinant of 0. Anytime you are solving for a matrix, the determinant is 0. That means it does not have a multiplicative inverse. Okay? So, another key thing, it's a little bit of an introduction today, and you're going to focus more on it in the future, but the absolute value of the determinant of a 2 by 2 matrix can be visualized of an area of a parallelogram. Remember, what did we use a parallelogram for? We used it to find the resultant of two vectors. So that's where parallelograms are playing into part again. We'll focus more of that in the future, but I do want to show you how it does equal this. So it says, note that the elements of the column of the matrix are used to be defined the endpoints of the vector form on the two sides. So this gives us the instructions of we have 0, 0, and we have AC, and we have BD for another. So it says use the following diagram, and we're going to label this horizontal distance from here to here as distance A, and the vertical height from here to here, C, based off this point. Now over here, the horizontal distance and the vertical distance right here is BD. Okay? All right, well that doesn't help us a ton over there. So let's see how else this could be helpful. So let's see. I know this was A. Let me go and come back over here. This right here, which we said before, is the height of C, so that's good. And then over here, we said that this horizontal distance was B, and this vertical distance of the whole thing was C. So let's go ahead and show what I have so far. So if this point is AC, horizontal to here is A, the vertical is C. So far, so good. Over here, I know that this vertical, so this piece right here, is D, and then that this part right here is B. All right. Well, if the horizontal distance to this point, since it's a parallelogram, remember, essentially this is just two vectors that we're adding, okay? This is essentially the resultant of adding these two vectors. What is the total horizontal distance? Well, if this is A, that must mean that this is B. Great. And if this vertical distance is CD, I know that this is D and this is C. So let's go ahead now and complete a few more pieces of this. I know that I can form this rectangle, and I know I can form this rectangle. Well, we can just go ahead and write the overlapping sides then. Let's see, so this is BC, this is BC, this is AC. Here we go. We have this triangle right here. Well, I know this base right here is C, and I know the vertical distance. Guys, remember the vertical distance is C plus D. And if this is C, then I would know that this is D. Okay, so all of that to say, that's a lot of information. Why do I need all of that? Well, what I want to do is figure out the area of this parallelogram. And to figure out the area of this parallelogram, I'm going to take the area of this entire square, and I am going to subtract these, this entire rectangle, and I'm going to subtract these pieces. Remember, what I'm trying to do right here is find the area of this parallelogram. So we're going to find the area of the entire thing, and what we are going to do is area of the entire thing and subtract these pieces in order to find it. So the first thing I'm going to do is, well, I know that I have length times width. Well, this is AB, or A plus B. This is C plus D. I'm going to multiply length times width. So if I take A plus B, and I am going to multiply that to C times D, I can do that with FOIL. First, outer, inner, last. So we're going to take A times C, so that's AC, plus A times D, plus b times c plus b times d. That is the area of the entire square. So I'm going to erase this in a second, but I keep saying square, but the entire rectangle. That's all of this. All of this. And what I'm going to do now, let's go back to, is subtract all these little pieces in order to get what I'm left with. So the first thing I'm going to subtract is this area right here. This is b times c. And if you look at that, I have another b times c here. So I'm going to minus b times c. I'm going to minus another b times c. All right. So let's see, what else do I got? So that took care of these two BCs. Now I have these four triangles. Well, let's see. This triangle, this has a base of C and a height of A. So the area of this triangle is 1/2 base times height, so A times C. And over here, this also area of this triangle is also 1/2 base times height, A times C. So if I subtract both of them, and there are two 1/2 A times C, I am going to subtract an entire A times C. Okay, so I'll mark this up in green. So I just subtracted this one, 1/2 of an AC, as well as another 1/2 of an AC. So now I'm left with this one with a base of B and a height of D, a base of B, a height of D. So let's see, in purple, I am now going to subtract both of these. I have 1/2 B times D and another 1/2 B times D. So if I'm subtracting two 1/2 B times D, that would be equivalent to subtracting 1 B times D. So now that I look at these, I have AC plus AD plus BC plus another, plus BD. So if I took away my BC, let's take away this BC, I take away this BC. Let's see, what else can I take away? Oh, here we go. I can take away this BD. I can take away this BD. Let's see, and then I have this AC, and I can take it with this AC. So everything is all subtracted except I have AD and minus BC. So that is the area of the parallelogram. It is AD minus BC, which, if you remember, is the determinant. Messy handwriting, sorry, I had to squeeze it in there. So guys, all this is to prove that the area of a parallelogram is equal to the determinant, okay? So now what we're going to do, draw a parallelogram whose area represents the determinant of the two matrices listed in the questions above. So if we looked at this, we had two matrices. We're going to define these matrices is the first one, well, let me go ahead and write it. It was 5, 1, 6, 2. This was my matrix. And what we're going to have, guys, is this first row will be my x's, and this will be my y. So when I have this first one would be 5, 6, and 1, 2. So I'm basically breaking these up into two smaller ones, and this is my x, this is my y. So my first one would be 5, 6, representing my horizontal and vertical movement. And then the second one would be 1, 2. Now when I look at this, it says draw the parallelograms. So we're going to start here. And the first thing from there, I'm going to go over 5. So we're going to start at the origin, go over 5, up 6. The second one wants me, starting from the origin, go over 1, up 2. Now to complete the parallelogram, we're going to do that again from the other side. Over 1, up 2. And then going back to purple, I can connect these. Oopsie doopsie. To draw my parallelogram. And you can easily see that the parallelogram, it's a parallelogram. Now let's see what happens over here. If I were to draw it, the other one was 6, 2, 3, 1. And going a little quicker, this would be 6, 3. This would be 2, 1. Starting from here, at the origin, I would go over 6 and up 1, 2, 3. No problem. And then this is what makes it not a parallelogram. Please go ahead and follow along when I draw the next one of going over 2, up 1. These are two pieces, two lines that lie right on top of each other. Therefore, we can easily see that this can't form a parallelogram. Okay. So now, guys, this next two parts, it's basically deriving a formula on how I can use this determinant in order to help me find the multiplicative inverse. So I am basically going to derive a shortcut so then you can use this shortcut when we solve it. Some of you might already know the shortcut, which is great, but please, guys, follow along on how to derive it. It might take a little bit of time. I understand it's going to be a lot of work, but please, like I said, follow along. Once we do the first two, it won't be that bad to find the other two. It's the same pattern. Because on your test, I may ask you to derive it, so you'll need to know this part, okay? Before we get there, though, it says create a matrix, the determinant will be negative. Draw a parallelogram associated with the determinant of your matrix and define the area of the parallelogram. So there's one thing. Area, distance can never be negative, but you can have a negative determinant. So let's say I have something like this, 1, 2, 5, 1. And it says find the determinant. Well, first off, how do I know it says find a determinant of the matrix? Remember, it's going to be defined as these straight lines. So over here, if I draw this, this would be 1 minus, so this is D times A, B times C, to get 10, which would be negative 9. Okay, if I am drawing this, this is telling me make a matrix that's like 1, 5, and then 2, 1. So it is possible to go ahead and draw this. So if I just go over 1, and then up 5, so this is all relative, and then over 2, up 1, you can see that this would be possible. It would just be kind of more of a shallow one. So it is possible to make a parallelogram. So I want you to realize when you find the area of a parallelogram, it's going to be, oops, and this will probably be on your test, so make sure we understand it. The area of a parallelogram is equal to the absolute value of the determinant. Okay, so now let's go back to the second part where we're actually deriving it. It says the determinant can be used to provide an alternative method to finding the inverse of a 2 by 2 matrix. It's actually much quicker. It's way more efficient. So it says use this process you can be used previously to find the inverse of a generic 2 by 2's matrix whose elements are given by the variables a, b, c, d. So it's basically saying, all right, here's my first matrix. It's a, b, c, d for a random matrix. For now, we will refer to the element of the inverse matrix as M1, M2, M3, M4. So one more time, A, B, C, D is just a random matrix. M1 through M4 is the multiplicative inverse matrix. Illustrated in the following matrix equation. Find the expression for M1, M2, M3, M4 in terms of the elements of the first matrix A, B, C, D. So guys, this is a fancy way of saying, how do I solve for the multiplicative inverse given a random matrix? So how do I derive the multiplicative inverse given a random matrix of A, B, C, D? So the first thing that we want to do is set it up as we always do. except this time it's all going to be variables. So like I said, please follow along. It can get a little confusing. But first row with first column, and so we're going to be deriving M1. So what I mean deriving, I want us to get M1 all by itself. I want to get M1 all by itself. So let's start by same idea. Row 1, column 1. This is A times M1 plus B times M3. So plus B times M3. And that's going to equal 1 like it always does. Now let's set up the second part of what we do. So to get there now, we're going to do second row, first column. So CM1 plus DM3, that is going to equal 0. Now remember, what I'm trying to do is get M1 all by itself. If I'm trying to get M1 all by itself, I know I would like to eliminate the BM3 and the DM3. So what I'm going to have to do then is multiply the top matrix by D and the bottom matrix by B as in boy. Therefore, the top matrix would be ADM1. So we're just distributing, plus BDM3 is equal to 1 times D, which is just D. And I'm just putting these in ABC order. That's why it's AD and BD. I will now distribute the B to the CM1 to get BCM1 plus BDM3 is equal to B times 0 is just 0. Now this is great because I can subtract these two. So ADM1 up here would be ADM1 minus BCM1. So those are different variables, so I'm just going to write minus BCM1. And then my BDM3 and BDM3 cancel out, and D minus 0 is just D. Well, second part here now, remember it wants me to get M1 all by itself. So, well, let's look at this. This term has M1, so does the second term. So I'm going to factor out an M1, and I would be left with A minus B is equal to D. Since I factored it out, this is multiplication, and I'm trying to get M1 all by itself. So when I go ahead and factor that out, oh, I'm missing some stuff. My apologies. Hold on. I factored out an M1. So what was left inside then, if I factored out the M1, is AD minus BC. My apologies there. Same idea though. I'm going to divide both sides by AD minus BC. Over here, AD minus BC. So that means if I were to get M1 all by itself, it would equal D all over AD minus BC. Very tricky, guys. Don't forget, we still have plenty of time to go over this if you have additional questions. But we're going to derive the other three now, M2, M3, M4, and I just want to see if we can see a pattern here. So I am trying to remember, this is the multiplicative inverse, and basically what does that first row, second column, how could I derive that there then? Just like we did before, if it was numbers, we're going to set it up. So now in orange, this would be AM2 plus BM4 equals 0. So second row, second column. Let's see. My apologies. First row, second column, because I'm trying to get this M2. First row, second column. and it equals 0. Now it's going to be second row, second column. Those are my two combinations on how I have the M2. So this would be CM2 plus DM4, and that's going to equal to 1. Remember, I'm trying to get the M2 all by itself, so I need to eliminate the BM4 and DM4. So what I'm going to do then is I'm going to multiply the top one by D and the bottom one by B. That would make these two variables exactly the same. So I would be left with, in ABC order, A, D, M2 plus B, D, M4 equals 0. I would then also do the next part, which is B, C, M2 plus B, D, M4, which equals B. All right, so then when I subtract these, the BDM4s cancel, and I would be left then with, let's see, we'll do this one in green so we can keep, here, I'll just draw like this. So then I would be left with ADM2 minus BCM2 is equal to 0 minus B, which is negative B. So then when I look at these, you would say M2, I factor that out, so what would be left in the factor is AD minus BC. How strange, another AD minus BC. And that's going to equal negative B. All right, so then what I'm going to do is divide both sides by AD minus BC. And that would leave me with M2 is equal to negative B all over AD minus BC. Remember, guys, what we have just derived on these first two of both M1 and M2 is essentially deriving how we get the terms for first row, first column, and first row, second column of the multiplicative inverse. So you would take a generic matrix and you would follow these steps. Not all of this, but essentially these two, M1 equals and M2 equals. The second thing I want you to look at is what are they both being divided by? They are both being divided by, by AD minus BC. Well, think about it. How else have we seen AD minus BC? And hopefully you figured out that is the determinant. So let's go ahead and continue this. We're going to do M3. We're going to figure out how to derive M3. So now over here, let me get another color. Let's go ahead and choose red. And first row, first column, once again. Oops, let me scroll up here. Let me go ahead and copy and paste this really quickly just so we can see it as we're writing these, as I would have to scroll down. Oops. And the computer's being a little slow. All right, let me just put this over here. And once again, this is just so we have a reference to this. So M3, this is first row, second column. Second row, first column. So to do that then, second row, first column would be MB times, M A times M1, B times M3, okay? So A M1 plus B M3 is equal to 1, and then C M1 plus D M3 is equal to 0. Very similar to the previous ones, but now what we're trying to do is solve for M3, get M3 all by itself. And so what we're going to do is multiply the top term by C and multiply the bottom term by A. Therefore, they'll both have a ACM1, and we can eliminate those. So what will that look like? Well, bottom right here will be ACM1. Next one will also, I'm going to do the whole row. My apologies. BCM3, and this will equal C. Bottom one, when I multiplied it by A, would be ACM1 plus AD, D as in dog, M3 is equal to 0. Now what I want to do is eliminate these in order to get rid of, right here, the ACM1s. So then what I would be left with is BC M3 minus AD M3 is equal to C. And then they both have an M3, so if I factor out an M3, I'll have M3 parentheses BC minus AD. That'll equal my C value. Now I'm going to divide both of them by BC minus AD. And that will give me M3 is equal to C all over BC minus AD. And while that is fully simplified, I do want you to realize this was AD minus BC. Well, what if I factored out a -1? So that means I'd have a negative C on top. And then this would turn into positive AD. And then the BC, if I factored out a negative, would turn to minus BC. Now, why do I do that? Well, as a reminder, AD minus BC is the determinant. And for each and every one of those, it's being divided by AD minus BC, or the determinant. So we've just done 3 out of the 4 of these. Let's do M4 really quickly. To derive the M4 of the multiplicative inverse, so second row, second column, what we want to do is create 2 systems of inequalities that both have the M4. So let's begin then by looking at, let's see, AM2 minus BM4 is equal to 0. And then we'll have CM2 minus DM4 is equal to 1. And what we're trying to do is get M4 by itself. So we want to get rid of these M2s. So to get rid of those M2s, I would multiply the top one by C and the bottom one by A, which would then give me ACM2 minus BCM4 equals 0. And then here I would have ACM2 minus ADM4 is equal to A. And when we eliminate these, when we subtract them, these would cancel. And negative BCM4 minus ADM4, we're taking away a negative. This would turn into a positive ADM4. ADM4. So we took away a negative. ADM4, and then this would be minus BCM4. And you could have had it negative BCM4 plus ADM4 and then reverse it, but just for the sake of saving time. And then we're going to have 0 minus A, which is negative A. So then from here, they both have an M4. So if we factor that out, M4 times the quantity of AD minus BC is equal to negative A. And then we divide all of this by AD minus BC. Divide this AD minus BC. And then we're left with M4 equals negative A all over AD minus BC. Wow, guys, that was a lot. We just derived each and every row, each and every column on how to figure out the multiplicative inverse for each one of these. So if I give you any given matrix and I want to find the multiplicative inverse, instead of doing everything we did before, you could just say M1 is equal to D all over AD minus BC. So instead of what we did in the warm-up, or up here, by setting up these, where is it at? Instead of setting it up like this, using a system, While this looks complicated, the complicated part is just understanding how we're actually deriving it. So let's go ahead now and talk about what all of this is. So it says, use your work above to explain this strategy of finding the multiplicative inverse. Okay, so first off, when they say find the multiplicative inverse, if I have matrix A, just so we know this, matrix A, the multiplicative inverse is going to have like an A times -1. So if A is the given matrix and we want to multiply it by the multiplicative inverse, this would equal then 1, 0, 0, 1. So just so what we know what this symbol means, you're going to be seeing this on the homework. This just means the multiplicative inverse of matrix A. So let's go on and review this. How did we figure out the multiplicative inverse? Okay, well, we derived it. We knew that to find the multiplicative inverse, given A, B, C, D, so given some random one, we knew that M1, which is what we just derived before, so everything what I'm about to write down is what we derived. We knew that M1 is equal to your D all over AD minus BC. So first row, first column was equal to D all over AD minus BC. Second thing, first row, second column, we derived that, this was our M2, was equal to negative B all over, once again, AD minus BC. So that's the first row, second column. Second row, first column was equal to negative C all over AD minus BC. And last, A all over AD, that looks like two D's in a row, let me fix that. AD minus BC. So, few things. This is what we need to know. We're going to actually factor one more thing out of it. Everything that I just wrote down was what we just did on the previous page of how to derive it. So you might need to know how to derive it, but the main thing is knowing how to get the multiplicative inverse. And if you notice these, on the denominator, these all have AD minus BC. Once again, what is AD minus BC? That is the determinant. So to find the multiplicative inverse, what you are going to do is take 1 all over the determinant, so I'm just factoring it out. And if I factor that out, you would be left with D, negative B, negative C, and A. So we're going to do a few examples, but once again, to find the multiplicative inverse, all you do is 1 over the determinant, and then you multiply that. You move the D value in the first row, first column. You change both the B and the C, just the negatives. And then you flip the A where the D was, so second row, second column. All right, a lot of mumbo jumbo there, but let's see if we can do this a little quicker. So find the inverse. So basically, guys, one more time, it wants us to find the missing, in the previous example, the M1, M2, M3, M4 in order to get the 1, 0, 0, 1. So how do I figure out this matrix? How do I find the multiplicative inverse, the inverse matrix represented by this A negative 1? Well, what we do is we first find the determinant. The determinant is AD minus BC. So negative 3 times negative 2 is positive 6. 5 times 1 is 5. So that means the determinant is 1. Now, if we're using this formula exactly, it said 1 over the determinant, so 1 over 1, times, and then I'll write this here, it was D, negative B, negative C, A. So we are going to take 1, and we are going to times it by 1 over the determinant, so 1 over 1 is just 1, and I'm going to take this negative 2, it's my D value, move it to my A value. So the negative 2 is going to go row 1, column 1. I'm going to take this negative 3 and move it where the D was. This is the row 2, column 2. And then I'm going to keep the 1, this was this value, and I'm going to make it negative. And I'm going to take this 5, and I'm going to make it negative. When I make it negative, I'm going to multiply it by negative 1. So what did I do there? I did exactly what it said up here. Make the a the d value, the d the a value, which I just did. Take the b, leave it there, just turn it, multiply it by negative 1. Take the c value, leave it there, multiply it by negative 1. And then what you're going to do is you're going to multiply it by the determinant, which would just give me same exact thing, because in this case, 1 over the determinant is just 1. So you'll have a final answer of the multiplicative inverse of negative 2, negative 1, negative 5, negative 3. Now really quickly, guys, what did I just solve for? If you were to take this matrix of matrix A and you multiplied it by the multiplicative inverse of negative 2, negative 1, negative 5, negative 3, you would end up with 1, 0, 0, 1. This will become very helpful when we're trying to solve for missing variables. So we can do the same thing over here now. So to do this, what we are going to do is first find the determinant. Remember, the determinant is AD minus BC. So AD is 1 times 4, which is 4, minus BC, which is 3 times 2, which is 6. So I'm going to have a determinant of negative 2. Then what we're going to do is take 1 over the determinant, and all I'm doing is what we just did up here. This is what we derived earlier. So let's look at this. You're going to take the A and switch it with the D. That's what the DA means. So instead of A, B, C, D, it's now D and A flip-flop. So the 4 is going to go in row 1, column 1, and the 1 is going to go in row 2, column 2. The B value stays the same, but we're going to multiply it by negative 1, which turns it to negative 2. And the 3 value is going to stay put, but we're going to also multiply that by negative 1. So then from here, we're going to do 1 over the determinant and multiply it at each piece in there. And so negative 1/2 of 4 is negative 2. 1/2 of negative 2 is positive 1. Negative times negative is a positive, and 3 times a half is 3 over 2. And negative 1/2 of 1 is negative 1/2. So right there, guys, we just quickly and efficiently solve for the multiplicative inverse of the matrix. So if we were to take one more time, 1, 2, 3, 4, times that by negative 2, 1, 3 over 2, and negative 1/2, that would equal 1, 0, 0, 1. Now remember, I was able to figure out what the determinant was, and if it had one or not, very easy in the previous one. So if I looked at this and I said, all right, A times D is 4, B times C is 4, I will get the determinant of 0. If you have a determinant of 0, this will not have the multiplicative inverse. Remember, if you were trying to draw the parallelogram, it wouldn't work. We couldn't do anything there. So right there, it's done. We're good. All right, last one here, multiplicative inverse. This is great because sometimes when we solve using substitution or elimination, it gets a little like weird fractions. It's hard to solve for. So this is going to help us with this. So one more time, to find the multiplicative inverse, I do A times D, which is 4, minus B times C, so which is negative 3. And I'm going to get a determinant of positive 7. Now, remember the formula. It's 1 over the determinant. And I'm going to multiply that times D, negative B, negative C, A. So if I were to plug all these in, then I will have 1 over 7 times, okay, the 4 is going to move to where the 1 is, so that's the 4. The 1 is going to move to the 4 is, so that's 1 right there. The negative 1 is going to stay put. I'm going to multiply it by the negative 1, which will give me positive 1. 3 stays put, multiplied by negative 1 to get negative 3. So then when I distribute this, I will get then my multiplicative inverse of 4 over 7, 1/7, negative 3 over 7, and 1/7. So this right here is your, what we call the multiplicative inverse, represented with the A to that negative 1. Remember what that's saying is if I took the 1, negative 1, 3, 4 and multiplied it by 4 sevenths, 1 seventh, negative 3 sevenths, and 1 seventh, you can quickly and easily get your multiplicative identity, the 1001. All right, so that's a lot of information about the determinant and how it's used to find the multiplicative inverse. I do realize, guys, that this page of deriving it can get a little tricky and a little complicated, so we can go over this when I get back. The key part of this is using any matrix of A, B, C, D. It can help you to derive using these parts of what M1, M2, M3, and M4 equals. And from there, this is the key part of the lesson. How do you take the determinant and with what and their given matrix can you find the multiplicative inverse? So with everything in this lesson, while you'll be tested on more than just one piece, this is the key part of the lesson right here. Okay, so make sure we remember this formula, the 1 over the determinant, so on and so forth, times D, negative B, negative C, A. At this point, you're able to start your homework. If you have any questions, do not hesitate to email me. If you want to have additional questions, please do not hesitate to come into Power Hour. I'll be more than happy to help you. Have a great day, guys.